Good morning. It's June 18th and this is your daily brief in science. Here's everything you need to know. The Vera Rubin Observatory in Chile is gearing up for a groundbreaking project, the Legacy Survey of Space and Time, or LSST, funded by the U.S. National Science Foundation and the Department of Energy. This initiative aims to revolutionize our understanding of the universe. Equipped with the largest digital camera ever constructed, boasting a 3,200 megapixel capacity, the observatory will capture high-definition images of the cosmos every 3 to 4 nights. This wide field of view will allow the LSST to detect real-time changes in the sky and observe rare celestial events, including supernovae and gamma-ray bursts. Rubin Deputy Project Scientist Federica Bianco highlighted that the observatory will generate data equivalent to filling 10 million books each night, contributing to an extensive record of the night sky. Over its operational lifespan, the LSST is expected to produce around 60 petabytes of data, which will be crucial for various astronomical inquiries, such as studying dark matter and dark energy. The data collected will also support research into phenomena like Earth-crossing asteroids and the structure of the Milky Way. The LSST aims to provide the most detailed time-lapse view of the cosmos, enabling scientists to observe 10 million moving objects and other significant astronomical events. A live-streamed event on June 23, 2025, will unveil the first images and videos from the observatory, marking a significant milestone in astronomical research. Global watch parties will invite both astronomers and the public to engage in this momentous occasion, with events hosted at planetariums, universities, and museums worldwide. The University of Delaware is organizing a public watch party starting at 10 a.m., with online registration available. Bianco also emphasized the role of artificial intelligence in analyzing the vast data, suggesting it could help uncover new cosmic mysteries. Researchers at the University of Georgia have made a significant breakthrough with a new vaccine named NXT-2, designed to protect against and treat vaginal yeast infections in mice. This development represents a major advancement in the fight against fungal infections, which are increasingly becoming a public health concern. The NXT-2 vaccine has demonstrated efficacy against the 3 most common fungal pathogens that account for over 80% of fatal fungal infections. It has been tested in various preclinical animal models, including non-human primates, showcasing its potential for broad antifungal immunity. The findings of this study have been published in Nature's NPJ Vaccines and indicate a pathway towards future clinical trials involving diverse populations. The initial clinical trials will specifically target women suffering from recurrent vulvovaginal candidiasis, or RVVC, a condition that affects hundreds of millions of women worldwide and incurs substantial healthcare costs. While RVVC is not life-threatening, it leads to significant healthcare expenses and affects productivity, with many women experiencing multiple infections each year. Current treatments for RVVC are limited and often lead to drug resistance, which can render them ineffective during pregnancy or in preventing future infections. Lead author Karen Norris highlighted the growing issue of antifungal drug resistance, noting that reliance on new drugs is not a sustainable solution as fungi adapt rapidly. The NXT-2 vaccine aims to reduce this reliance on antifungal medications and prevent future infections, addressing a critical public health need as antifungal resistance continues to rise. This advancement paves the way for clinical trials in humans, with the goal of being the first vaccine to prevent pathogenic fungal infections, which the World Health Organization identifies as a major public health threat. Future trials will also focus on high-risk groups, such as transplant recipients and cancer patients who are more susceptible to serious fungal infections. The study was co-authored by several researchers from the University of Georgia's Center for Vaccines and Immunology and other institutions, highlighting the collaborative efforts in addressing this pressing public health challenge. As fungal infections become more prevalent among individuals with immune disorders and other health conditions, the need for effective prevention strategies is increasingly critical. NASA engineers are gearing up for a historic mission, aiming to send the first astronauts to explore the lunar South Pole through the Artemis 3 mission. This initiative is notable not only for its ambitious goals, but also for the collaboration with SpaceX in developing the Starship human landing system, which will safely transport astronauts to and from the Moon's surface. The preparations are taking place at the Flat Floor facility in Huntsville, Alabama. This facility is equipped with one of the largest air-bearing floors in the world, allowing for frictionless movement of objects, closely replicating the conditions on the lunar surface. Engineers are using high-intensity lighting and lunar mock-ups to simulate the extreme lighting conditions astronauts will face on the Moon. By utilizing powerful lights, they are able to mimic the low-angle, high-contrast lighting found at the Moon's south pole. This is critical as shadows can stretch significantly and bright sunlight can create blinding effects, impacting visibility. Emma Janes, a test engineer, emphasizes that understanding these shadow effects is vital for astronaut safety and mission success. The testing not only improves training models for astronauts, but also aids cross-agency teams in evaluating tools for lunar operations. The facility allows engineers to observe lighting effects from multiple angles, enhancing mission planning. The Artemis 3 mission is building on advancements from previous missions and integrating new technologies, laying the groundwork for future crewed missions to Mars. Overall, the Artemis program aims to foster scientific discovery, economic growth, and prepare for the next steps in human space exploration. A groundbreaking study from the University of Cambridge is pushing the boundaries of cancer research by employing an AI scientist, specifically the large language model GPT-4, to uncover new drug combinations for breast cancer treatments. This innovative approach not only generates scientific hypotheses, but also evaluates their validity through laboratory tests by human researchers, marking a significant shift in how scientific research is conducted. This research is notable as it represents the first instance of a closed-loop system where experimental outcomes directly inform the AI's suggestions, which in turn guide further research efforts. The team focused their experiments on the MCF7 breast cancer cell line, a standard model in breast cancer research, and compared it with the MCF10A normal breast cell line as a control. In initial laboratory tests, GPT-4 identified 3 effective drug combinations out of 12 tested, achieving synergy scores that exceeded those of existing breast cancer drugs. A subsequent round of testing allowed GPT-4 to refine its hypotheses, yielding 3 additional successful combinations from just 4 tested. The researchers tasked GPT-4 with identifying drug combinations that specifically target cancer cells while minimizing harm to healthy cells, addressing the common adverse effects associated with standard cancer treatments. Additionally, GPT-4 focused on affordable and effective combinations that are FDA-approved and deemed safe for normal cells. Breast cancer remains a leading cause of cancer mortality worldwide, predominantly affecting women, which underscores the significance of this research. The findings highlight the potential for AI to act as a collaborative partner in the scientific process, suggesting a transformative shift in methodologies that integrates AI scientists alongside human researchers. Moreover, this study indicates that AI models like GPT-4 can assist scientists in exploring novel hypotheses that may be overlooked due to human biases or limitations. While the drug combinations identified show promise, they will require extensive clinical trials before they can be considered for actual use in cancer treatment. Researchers in India have made significant strides in cancer treatment with the development of a novel one-step colloidal synthesis method for creating nanoparticles that feature a unique semi-shell nanocup morphology. This innovative approach employs a rhombic dodecahedron-shaped metal organic framework, known as ZYF8, as a sacrificial template, while utilizing mild reducing agents like ascorbic acid at room temperature. By avoiding harsh chemical conditions, this method simplifies the fabrication process, reduces costs, and enhances environmental and biological compatibility compared to traditional multi-step techniques, which are often labor-intensive and involve toxic substances. To ensure stability and safety for clinical applications, the new semi-shell structures are modified with polyethylene glycol, or PEG. In preclinical trials involving mouse models with advanced metastatic breast cancer, these pegylated semi-shell nanoparticles exhibited high photothermal conversion efficiency, effectively reducing tumors and improving survival rates. The results indicate a significant improvement in survival and a reduction in tumor relapse, suggesting a promising future for advanced breast cancer therapies. This synthesis technique offers numerous advantages, including the avoidance of harsh chemicals, processing at room temperature, enhanced biocompatibility through pegylation, and high stability with low toxicity during treatment. The nanoparticles demonstrate strong light absorption and scattering in the near-infrared spectrum, making them particularly suitable for effective photothermal therapy. This breakthrough represents a notable advancement in cancer treatment, with potential real-world medical applications, especially in resource-limited settings. The research team, which includes the Institute of Nanoscience and Technology, ACTREC, and IIT Bombay, plans to further investigate the combination of chemotherapy with photothermal therapy. They are also exploring the potential for these nanoparticles in advanced diagnostics using techniques like surface-enhanced Raman spectroscopy, indicating a broad scope for future research and medical innovation. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.